right, welcome everyone to the Warehouse Simulation webinar, hosted by myself, Jonathan Callan, and Jonathan Yiv, representing Cycle Labs. Just to kind of introduce myself, I've been with Longbow for 11 years now. I started on the consulting side, implementing WMS systems for Blue Yonder specifically. I have a lot of experience with warehouse management, deployments, and go-lives, and recently I've moved into the Rebus realm. And we started exploring warehouse simulation. Jonathan, you want to introduce yourself?
Yeah, of course. Hey, everyone. Pleasure to be here. My name is Jonathan Yiv. I work with Cycle Labs, and this simulation is kind of a joint initiative between powered by Rebus and Cycle. So just a little bit of background on me. So before we dive in regarding the simulation and what it is and what it aims to achieve, I've been with Cycle for about 5.5 years. If you're familiar with restaurant terminology, you can think of me as someone who's worked front of house and not quite back of house, but middle of house. So when it comes to how the simulation operates and how things are put together, we'll kind of dive into that later in the presentation today. So really excited to talk to you about this. Pass it right back to you, Jonathan.
Yeah. So as we go through the presentation, if anyone has any questions, we'll be answering them at the end. You can enter all your questions in the Q&A tab on the right there, and we'll answer all your questions then. So yeah, let's get started. Great. So Rebus and Cycle have partnered to explore warehouse simulation. Kind of how all this started was basically a few years ago when I was on the consulting side implementing Blue Yonder WMS. A client kind of posed an interesting question to me. The customer basically asked me, hey, we're exploring implementing interleaving work as opposed to users being dedicated to certain types of work. In theory, it should work, but we don't have no idea in a day of life, right? We can hop on and do a few test scenarios and it will look good, it seem efficient. But as the warehouse is flowing through inventory, receiving, put away, as we get honeycombed in our replenishments, is there a threshold where interleaving actually would not be beneficial? Also, we want to kind of see how priorities are set and what the work queue looks like after we've run this simulation. So at the time, I didn't really have a solution for them. But revisiting with Cycle Labs, we thought, hey, this is kind of something good we could explore utilizing Rebus analytics and figure out what kind of metrics and widgets we can help gauge that, gauge those questions of, hey, what if we change the way we worked in our warehouse and see what a day in the life looks like. So this can help with analyzing any type of certain configurations for future planning, re-warehousing, or even planning for new warehouse implementations. Okay, so one of the big questions is what metrics determine success or failure? We kind of determined through iterative approaches that different configurations of WMS and having large data sets, how can we compare, the efficiency of that simulation? So kind of boiled down to looking at goal times and travel distance and certain volumes being ingested into the system. So maybe we have a high volume peak season demand and we run a simulation on that, or we do low volume and we compare the results through goal times and travel distances. On top of this, once we run our simulations, we can compare it to our actual data in production. Feedback we've kind of received with other warehouse simulation software is that, visually they look good. You can see all the forklifts moving through the warehouse, but they lack kind of the data that we need to kind of judge if what our simulation is accomplishing what we want, or it's not, it's not a good configuration. So one of our strategic partners is Mars Pet Care, and they came to us and they wanted to explore the concept of a warehouse simulation with certain use cases that they provided us. So we basically boiled down to creating a proof of concept and simulating 4 work areas. So we wanted to look at picking, and we wanted to look at replenishments, receiving, and put away. And we basically wanted to simulate a certain number of users performing that work and track the data in Rebus. So the use case that Mars wanted to see is, hey, I have an AGV workforce and I have my standard workforce on forklifts. I want to compare their performance. I want to see if, if I have 50-50 workforce, is my efficiency going up? If I have all AGVs, does my efficiency go up? And this was kind of our base test case to see how Cycle would work with Rebus. So we started creating the proof of concept, and I'll just show the next slide. We're still working through the actual data on the Rebus side, but essentially what the output data is going to look like this. You're going to have all your simulations kind of paired up against your actual goal times and travel distance. So if you can see, the red bar on the left is our simulation 1. We can see that it's slightly better than our actual, which is the goal bar on the right. And for each work function, we have this set of bars to kind of show you how efficient whatever configuration you have done. So on top of that, with our output data, we can also link it to warehouse maps in Rebus, which kind of shows, this map kind of shows you all the areas that were hit hardest with picking or replenishment. So red indicating that, there was a lot of kind of congestion or a lot of kind of hot zones in that area. So we can also display that data as well. Finally, we are exploring some more use cases with Mars. We want to look at robotic setups like conveyor system or ASRS systems. We want to look at performance between more user groups. Maybe some re-warehousing, so looking at kind of like racking or unused racking and how that would work with your configuration. Also looking at work zone setup to handle priorities and deltas. And then also looking at dock doors to stage to aisle optimization. And then any other kind of configuration regarding picking, so allocation configuration, replenishment configuration, all of that, all of that is able to be kind of simulated with Cycle Labs and Rebus. Then there was the original use case I had with interleaving, and all of these can assist with cost benefit analysis. So with that, I think that's everything I wanted to cover. Now I will talk also about timeline. So the timeline to set all of this up is basically, for Mars specifically, we got our base simulation set up in about 3 to 5 weeks. Everything in Rebus works out of the box except for the custom metrics that you want to build related to simulations. And I guess at this point, I'd also encourage anyone, if you have any other use cases you can think of within your own operations that you might think would work well simulating and tracking in Rebus, to please reach out to us and we can look at those as well. So that covers everything I had. I'll turn it over to Jonathan now, who will talk on how the data is generated.
Fantastic. Thank you, Jonathan. And you all may have noticed that there are 2 Jonathans on this call. That was intentional. We did find the correct name, so it's easy to refer to us. So before you hit play on that screen, because I think you have control there, I do want to kind of tie it back to what Jonathan was saying. Really, this is about the questions that you are asking in your warehouse, and how affordable and how achievable it is to get answers to those questions. Does this work better? Does that work better? So every use case that I saw Jonathan had on the screen there, being probably fairly expensive to set it up and then put it into play, and potentially maybe it's not the right configuration set, and that can be expensive to kind of discover and implement. So really excited about this. So today, what I want to show you, we've seen kind of the Rebus side, the actionable results. You see kind of the widgets, the screens that let you make judgments about your experiments. They'll let you go, this is my question, this is my hypothesis. I think this is more efficient by 7% than this, and that will save me Y dollars over the years. So you've kind of seen the visible things that help you make that judgment call. So what we're going to do now is we're going to look under the hood and we're going to see how Cycle is kind of generating the data to help inform this. So on the screen here, I'm going to run a little bit of a demonstration video of a recording of the actual simulation itself. Do you mind hitting play for me, Jonathan?
Sure.
Thank you. Fantastic. Let's see when it starts. All right. So let's talk about what we're seeing on screen here. You can obviously see quite a few devices have been spun up. These devices are doing a variety of business process flows. So there's about, let's say, 36 to about 15 or so workers there. They are doing pallet picking. They are doing pickup and deposit. They are doing put away. They are doing receiving. In this video, you can see just all the different work types being spun up by Cycle in parallel. So in any given simulation, Cycle would receive some amount of receipts, pick for shipments, do it for an extended duration based on how much data was created. And you can kind of hear the dinging, which is kind of a nice little helpful accent to indicate how much work is being done. So all of this runs and produces the transactional data necessary to fuel Rebus and the views you saw earlier. So Jonathan, if you don't mind clicking forward in the video just a few times to kind of just snapshot of where it is. Yeah, just like skip through it by like multiple minute increments. So if anyone has any questions about what they're seeing up here, again, Q&A to the right. But with that, Jonathan, if you don't mind switching to the next slide.
Sure.
Thank you, sir. All right. So you've now seen this kind of simulation go. You've seen all of these workers spinning up, performing all these business processes at once. So I want to talk a little bit about what exactly is happening. How do you get this simulation to produce that data? So at a high level, you're going to do 4 steps to run this thing. 1, you're going to take a database backup, and this has all of your orders, your receipts, your trailers, your inventory, your carriers, your shipments, all that. And then you're going to put it right into your test database, into your test environment. And you already have a pre-existing backup that's been seeded with this data. And you can just insert it as many times as you like as it changes. Once that data is in there, you're going to, step 2, you're going to run your simulation. You're going to have your VNA AGVs going into the very narrow aisles and having those guided vehicles picking and doing put away. You're going to have fork trucks moving between the P&D locations and the staging locations and the inbound trailers, and the simulation will run. Step 3, you're going to restore the database backup again so that your test environment is unaffected, back in a neutral state where other people can use it for other things they're doing. And then step 4, you'll kind of parse out that data and analyze it in Rebus. So that will allow you to take a look at that view that you saw drafted earlier, and you'll be able to look and go, what's the answer to my hypothesis? And maybe you won't get a quick answer. Maybe you'll go, I need a tweak. I want to adjust my configurations. I want to tweak this. I want to adjust the ratio of AGVs to humans. And you try again. And you just follow steps 1 through 3, look at the results, and kind of get closer and closer to understanding what an ideal configuration that would be optimized would be. So that's kind of the step-by-step walkthrough of how you run the simulation. Mind heading to the next slide for me, Jonathan? All right. So we've now seen a sort of brief video showing the simulation running. And actually just yesterday, it ran for a straight hour. Could have kept going if we wanted it to, but we just wanted to do a quick mock run. So it could go for hours if you like and emulate the data that you're trying to achieve. So finally, I kind of want to just talk a little bit about what is it actually doing. So here's a little flow chart. So you can see here between the VNAs, the very narrow aisle storages, Cycle is basically emulating two AGV flows. It'll have an AGV pull from storage for picking, pallet picking, and that'll be for outbound shipments and for replenishments. Drop it at a P&D location. And then on the way back, if it can, it's going to alternate between these 2 types of work. It's going to grab something from the P&D locations for things that are coming inbound, and then send that for directed put away back to the VNA storage. And that is the effective loop of cycle doing those two things together. From the P&D locations, one will be filled by fork trucks bringing things from receiving staging from the trailer, and the other will be sending things back out to the pick face storage for replenishments or to shipment staging. And Cycle is doing all of that in order to produce the data that's necessary for Rebus. So what's interesting about this is when it comes to Cycle, you don't have to staff humans and purchase actual VNA AGVs to simulate this flow. You just set it up to do so. Like Jonathan mentioned, this first iteration took 3 to 5 weeks of time to put together. But this is just the first iteration. Like Jonathan showed, there's a lot more experiments and hypotheses you could run. You could expand on this. You could deepen with the current flows to make them more robust or reflect reality even closer and get even more answers. And what's nice about this is we've kind of designed our platform for this specific use case. All of these automated flows weren't built from scratch. We have a library with pre-built architecture to perform things at load that have pre-existing test flows for put away, for pallet picking, for receiving, for pickup and deposit. And these were simply repurposed, slightly customized to fit the Mars Pet Care business process flows to work for this. So we were familiar with the challenges of setting things up, and so we found this was a really pragmatic use case of what we had built. So hopefully this was interesting to kind of see under the hood and understand how the Rebus visibility kind of comes into play, how we can begin to answer these questions. So I appreciate you all hearing me out. Without further ado, I think I'd like to pass it back to Jonathan as we kind of head into a section.
Yeah, and just to reiterate, for our specific test scenario with Mars, we opted to do all the work instantaneously, so that in a day's demand, we ran it in I think it was a few hours to kind of determine the goal time travel distance. But we do have the capability of simulating as if the workers were working throughout the day, just for timing and proof of concept. We kind of cut that out for this presentation. So yeah, I'll move on to Q&A if there's any questions.
All right. It looks like we got our first question. How much volume of data do you generate in that 1 hour run? So I think, Jonathan, we were trying to get that extracted.
Yes. So for the specific scenario that we ran with Mars, we had 75 orders and 4 working. So it was a roughly close to a few thousand records that we were processing into labor at once.
Yeah, and I think, as Jonathan said, you can kind of control the rate with which that data gets consumed. Mm-hmm. We opted for a more realistic flow, so it'd be more relative, I think, analyzed for a peak hour, but you could have it go faster if you so wish and process it at a faster time. You just need to spin up, as you saw earlier, a bunch of workers. You just spin up more of those workers to do that work simultaneously.
So next question, are you able to control how many shipments or types of shipments that go into the simulation to test out scenarios for expected difficult peak periods? Yes, that's a good question. We basically can take a copy of your current production volume, or we can alter it to be either low volume or high volume demand to go into the simulation. Basically, the simulation doesn't look at what the demand is. It just runs through the actual work.
Mm-hmm.
So whatever is out there, it'll pick it up and start working on, basically.
Yep. And the next question, can the test database be used for anything else when Cycle is actively running? So to answer your question, yes, you can use your test environment for other things while Cycle is actively running, but you have to be careful about it. You have to make sure that what you're doing manually or with other automated tests or whatever you're doing in it doesn't interfere with the simulation under the hood. So as a best practice, we generally recommend not doing anything at the same time, but with some good policies and training internally, you can certainly do things at the same time. We've done it before. It is easier if you don't.
Yeah. because you have to think about that. The cycle script is going to try to look at that inventory, look at what picks are available. You might not want to overstep those work functions.
And then the next one was Heston's question. In step 2 of the slide, are we able to put the slide back on screen so we can refer to it as we answer? Yeah. Is it customizable with various different types of rules? Like sort of business process flows. So yeah, and that's kind of what I was alluding to earlier, is in this pre-built library, there are a bunch of different simulation flows that you can incorporate. So I think there's about 9 to 11 flows that are pre-existing that you could tweak to your custom, business processes. But if you have others, you can certainly build them either from scratch or using pre-existing building blocks that contain a portion of it. So hopefully that answers your question, Heston. Feel free to ask a follow-up if not. Next one for you, Jonathan.
Yes. Yeah. So because we built the test connection within the Rebus platform, we're able to use the simulation data and compare with your prod. So you can make widgets that cross between the simulation and prod to compare actuals versus what we simulated. Well, thank you, everyone. Have a good rest of your day, and I hope this was interesting or stimulating to give us more ideas.
Yep, absolutely. We appreciate your time, and thank you so much.